Hello everyone. Welcome to First Online University, a global platform for all your education and growth related needs. In this lecture, we are going to begin with a new chapter that is stoichiometry. It can also be pronounced as stoichiometry, that's up to you. So when we talk about stoichiometry, we are going to discuss a lot of important concepts which may not be asked directly in your exam as a question, but this concept is going to be used in each and every aspect of chemistry, be it physical, organic, or inorganic chemistry. In this lecture, we are going to focus on the introduction to this chapter, and as we move on to the other forthcoming lectures, we will be moving towards more advanced levels henceforth. Before we begin, a piece of information for you. You can use the coupon codes Mission JEE or Mission NEET while you enroll at First Online University for Mission JEE or NEET. Let us discuss the introduction to this topic first of all. So, the word stoichiometry is basically derived from two Greek words, stoichion, which means element, and metron, which means measure. So measuring the amount of element that is present is what we refer to as stoichiometry. So this chapter is very useful to describe the physical properties of matter quantitatively by making use of numerical values along with suitable units. So when I talk about matter, matter can be further classified into mixtures and pure substances. Now, obviously, why are we separating the two? Because pure substance is something which is like uniquely present here in that particular given container or whatever you are taking. However, when I talk of the mixture, it consists of two or more pure substances, but now they are no more pure because they are present in a mixture. Now, pure substances can be further classified into elements and compounds, and mixtures can be further classified into homogeneous and heterogeneous mixtures. Let us discuss what is matter first of all. So matter is anything we have already discussed when we were talking about the chapter states of matter. There we said that matter is anything which has mass and it's going to occupy some space. So anything, be it chair, pen, table, any and everything that you see around yourself which has got some mass, because when you lift it, you feel that it's heavy, or if not heavy, it has got at least some weight. Okay. So that, and it is occupying some space. So both these characteristics together help in classifying anything as matter. Okay. So if we look at the various mixtures that we have. So in matter, we have mixtures and pure substances. Let us talk about mixtures first. Now, the variable composition that is present in the mixtures is an important characteristic of the mixtures. Also, the components that are present in a mixture are going to retain their characteristic properties. May be separated into pure substances by certain physical methods. So it might be possible to separate the components of the mixture into pure components by making use of some physical methods. So this is where I'm discussing the characteristics of mixtures. Then mixtures of different composition may have widely different properties. Okay, so if I have A and B components that are present in a mixture, so the properties of the mixture are going to be different with different amounts of these components. So say first of all, A and B in say first container are present in first say conical flask. A and B are present in the ratio 1:2. But in the second conical flask, A and B are present in the ratio 2:1. So that is going to completely change the properties of the two mixtures in the two containers. When I talk of table, that's also matter because it has got mass and it is occupying space. For example, air, milk, gasoline. Now, what are pure substances? Pure substances are going to have a fixed composition. They cannot be separated by simple physical methods. It's very difficult to separate, okay, the pure substances by simple physical methods. And also, if they are already pure, there is no need for us to actually go into further separation methods. Then their properties do not vary. For example, diamond, graphite, glucose, which has a fixed composition of carbon, hydrogen, and oxygen in it. So pure substances are further classified, we have seen, into elements and compounds. So when I talk about elements first, an element is basically, the difference between the two is basically when we have an element, it's going to have just one type of atom. When I talk about compound, it's going to have more than one type of, two or more types of atoms present. So elements which has only one type of atom present, it cannot be further decomposed into simpler substances because it has only one atom. How much further are you going to simplify it? It's not possible. Secondly, sodium, hydrogen, copper, oxygen, silver, all these are examples of elements. These are all elements in the periodic table. This is something that we know. So they cannot be further broken into simpler substances. That is also something we know. So from these examples of these elements, we can easily understand the characteristics or properties of elements. Moving on to compounds. Compounds contain two or more elements which are taken in a definite proportion by mass, that I've already told you, and the constituent elements. So whatever the elements are present in that particular compound will not retain their properties. So if we talk about a compound, say H2O, H2O, that is water, is comprising of two atoms of hydrogen and one atom of oxygen. If we talk about the individual properties of hydrogen and oxygen, they are not going to be present in water. Okay, so the properties of the individual elements are not going to be retained in the compound. Similar is the case with carbon dioxide or ammonia also. So mixtures, coming back to mixtures now, mixtures are further classified into two types, homogeneous mixtures and heterogeneous mixtures. So as is clear from the name, homogeneous means when everything is present in one phase, okay? So it's like everything gets miscible with each other, or they get mixed with each other in a way that we cannot actually visually differentiate as to how many components are present. But heterogeneous is something that can be easily distinguished or differentiated on the basis of what we see or in terms of the color differences, etc. Let us now look at, so this was the layman terms definition for you to understand what is homogeneous and heterogeneous. Let us now talk about the scientific definitions of these terms. So first of all, we will discuss homogeneous mixtures. They have the same composition throughout. Okay, so that's the definition of homogeneous mixtures, that they are going to have the same composition throughout. The components which are present are indistinguishable, that is, we cannot distinguish or differentiate between them. For example, if I talk of a sugar solution, so you take water, you add sugar to it, you dissolve sugar. Can you differentiate by looking at it that this is plain water and this is sugar solution? No, you cannot, because it's a homogeneous mixture. It has the same composition throughout, right? Then gaseous mixture, if you talk about air, can you, by looking at air which is present in, say, a glass container, can you say that it has different components? No, we cannot do that, because gases, they so, very well gel with each other that we cannot actually distinguish between these separate components. Next is heterogeneous mixtures. Now, these do not have the same composition throughout, and they can easily be distinguishable. The components are easily distinguishable. For example, water plus kerosene. So if you look at this picture, you will see that water and kerosene are immiscible and they are going to form two separate layers, and it becomes very easy and simple for us to distinguish between the layer of water and layer of kerosene. So that is going to be an example of heterogeneous mixture. Right. Now, what are the properties of matter and how do we measure them? That's something which is important. So every substance has got some unique characteristic properties. The measurable properties of matter are expressed by certain specified units only. Okay. Let us see. The properties of matter can be classified into two types. What are two types of properties? Physical properties and chemical properties. Now, what are physical properties? We already know that physical properties are those that we can measure or we can observe without changing the identity or composition of the substance. So without doing any sort of reactions or introducing or eliminating anything, we can actually find out certain properties, and those properties which do not involve any such changes in the composition of the substance are known as physical properties. For example, the color, odor, that is smell, melting point, boiling point, density, all these are examples of physical properties. The second classification is chemical properties. Those properties that can be measured or observed only through a chemical change being brought about to the substance are called chemical properties. For example, basicity, combustibility. So if I want to look for basicity, I'll have to add some acid to it in order to make sure that the salt and water formation is taking place. Then I will say that yes, the given compound is basic in nature. If I want to check out for combustibility, I will have to burn the compound or heat the compound over a Bunsen burner or in a over a flame or in an oven to actually check out for the combustible nature of the compound. Now let's do a concept check. Matter is nothing but, your options are has mass, occupies space, both A and B, no correct definition. So obviously we know that matter, we have discussed matter is something that has got mass and it occupies space. So option C, that is both A and B, is correct. Now let us move on to the International System of Units. Now what is International System of Units? That is SI, right? So it should be IS basically, but SI, International System of Units. So the base physical quantities and their units, if we look at, so the first column is going to give the physical properties that we are going to talk about. The second column is going to give us the symbol that we commonly use to represent that physical quantity. The third column gives us the SI unit, and the fourth column gives us the symbol that we use for that SI unit. So this is something you all are aware of till now, right? So this is something that we have discussed in our lower standards also. So this is not anything new for you, but still we will just go through it. So length represented by L has SI unit meter given by small m. Mass, which is given by symbol M, has the SI unit kilograms given by kg. Time, capital T, has the SI unit second, which is given by small s. It's not capital S here, it's small s. Then electric current, which is given by the symbol I, is having the SI unit ampere given by capital A. Temperature, I think there is, okay. So the symbol for this quantity is small t. For temperature, it's usually capital T that we write, and for time, it's usually small t that we write. But that depends on whatever is given in the question. You will have to follow those standards only. Then temperature has the SI unit Kelvin, which is denoted by K. Amount of substance, that is N, has the SI unit mole, which is given by MOL. That is the denotation. Then luminous intensity, IV, is having the SI unit candela, which is given by small cd. Okay, so these are the various physical quantities, their symbols and their SI units, and the symbols of their SI units that we have just talked about in this slide. Now, what is the definition of SI base units? When I say SI units are being used, what do you mean by SI units? So when we look at the unit of length, which is meter, the meter is the length of the path that is traveled by light in vacuum during a time interval of 1 upon, which is approximately taken to be equal to 3 into 10 raised to power 8 meter per second is right how we define it, of a second. Okay. Then unit of mass, which is kilograms, is the unit of mass. It is equal to the mass of the international prototype of the kilogram. So this is just an additional knowledge. Okay, this is not usually asked in the exam. This is something that you should know just for the sake of knowing it. Then unit of time, which is second. The second is the duration of 9192631,770 periods of radiation corresponding to transition between two hyperfine levels of ground state of cesium, that is cesium-133 atom. Okay, you do not, I'm again telling you, you do not have to memorize anything. You just have to know it for the sake of knowing it, for your knowledge. Next, we have the unit of electric current, which is ampere, which is the constant current which is maintained in two straight parallel conductors of infinite length of negligible circular cross sections, and they are placed 1 meter apart in vacuum, that would produce between these conductors a force that is equal to 2 into 10 raised to the minus 7 Newton per meter of the length. And then we have the unit of thermodynamic temperature, which is Kelvin. Unit of thermodynamic temperature, Kelvin, is the fraction 1 upon 273.16 of thermodynamic temperature of the triple point of water. What is triple point of water? That you will get to know when we are talking about the phase diagrams. Okay. Next is unit of amount of substance, that is mole. So mole is the amount of substance of a system which contains as many elementary entities as there are in 0.012 kilograms or 12 grams of carbon 12. Its symbol is MOL, mole. When the mole is used, the elementary entities as must be specified and may be atoms, molecules, ions, electrons, other particles or specified groups of such particles. Why am I reading it out to you? Is so that when you listen to it once, that gets into your ears and at least 10-20% of it is retained just while you listen to it. Okay, I could have skipped these slides also because they're not so important, but why am I reading them out is so that it gets into your ears and you are able to remember at least some part of it, because you are supposed to know all of this. Then unit of luminous intensity, candela. The candela is the luminous intensity in a given direction of a source. Okay, so there's a source, then a given direction of a source that emits monochromatic radiation, that is a single wavelength radiation, frequency 540 into 10 raised to power 12 hertz, and that has a radiant intensity in the same direction, that is 1 upon 683 watt per steradian. That's your homework to check out what is this steradian. Okay, next is multiple prefix and symbol. So if we have the multiple 10 raised to power minus 24, that's called yocto. The symbol is capital Y. 10 raised to power minus 21 is zepto, symbol Z. 10 raised to power minus 18, atto, symbol small a. 10 raised to power minus 15, femto, symbol F. 10 raised to power minus 12, pico, symbol capital P. 10 raised to power minus 9, nano, symbol small n. 10 raised to power minus 6, micro, symbol mu. 10 raised to power minus 3, milli, symbol small m. So from 10 raised to power minus 3 to 10 raised to power minus 15 are the most commonly used ones. The first three ones are very rarely used, okay? Then 10 raised to power minus 2 centi, small c. 10 raised to power minus 1 deci, small d. 10 is deca, da. 10 raised to power 2 is hecto, h. 10 raised to power 3 is kilo, k. 10 raised to power 6 mega, capital M. 10 raised to power 9 giga, capital G. And 10 raised to power 12 tera, capital T. Talking in terms of chemistry, from this particular slide, centi, deci, deca, kilo, mega at the max are the most commonly used ones. And for the previous slide, I've already told you. So you should be knowing the values of these prefixes. Okay, that is what you're supposed to know. Or what you should be knowing is the multiples, that if multiples are given to you, what is going to be the answer. So if you get the answer in, say, say you get the answer as 3.68 into 10 raised to power minus, or into 10 raised to power 6 watts. Okay, and the question contains answers as 3.68 megawatts, 3.68 gigawatts, 3.68 terawatts. So for that, if you're getting as 10 raised to power 6, if you know that 10 raised to power 6 means mega, then only you will be able to take the correct option. So that is where the importance of these terms lies. So this was important, okay? Not maybe the definitions of these units that we have discussed, like the unit of meter and the definition of, sorry, unit of length, the definition of meter, all that was not important. But these two tables that I have just shown are really important. Even this one, 10 raised to power 15 is peta, that is capital P. 10 raised to power 18 is exa, that is capital E. 10 raised to power 21 zeta, Z. 10 raised to power 24 iota, small y. So that you can compare with 10 raised to power minus 24 and 10 raised to power minus 21. It's the same. Now let us do a multiple choice question. What is the triple point of water? Your options are 1 upon 73 degrees centigrade, 1 upon 273.16 degrees centigrade. Option C is 1 upon 200 degrees centigrade and none. Obviously, the answer is 1 upon 273.16 degrees centigrade. We have already discussed it in one of the previous slides. Now, what is the unit for luminous intensity? Options are ampere, mole, candela, or Kelvin. What's the right answer? Yes, candela is the right answer. Third question. What is the symbol for electric current? I'm not asking the symbol for the unit of electric current. I'm asking the symbol for electric current. L, T, M, or I? I is the correct symbol for electric current. Now let us discuss very simple basic concepts, that is mass, weight, volume, density, and temperature. Now, let us first see the difference between mass and weight. So, mass of a substance is basically the amount of matter that is present in it. See, these are the questions that will not be asked in your exam, but when you go for interviews, job interviews, etc., these are the basic questions that are going to come to you, and you will not be able to answer these questions just because you never had this concept clear in your mind. So I do not want that to happen, especially when you are putting in so much efforts to prepare for such exams. I just want you to be clear with each and every basic. If you are studying huge essays, you should be clear with the alphabets also. Okay, now what is weight? Weight is basically the force that is exerted by gravity on an object. So mass is the amount of matter that the object contains, which will not change at any cost. It will remain the same at each and every place you go. But weight is basically the gravitational pull that the object is experiencing. And with the change in the gravitational pull, because of the changes in the position that we go to Earth and different positions in the Earth, the gravitational pull is going to change, and therefore the weight of the object will also change. The mass of a substance is constant, whereas its weight may vary from one place to another due to change in gravity that I've just told you. So a man who is standing on moon and a man who is standing on Earth will have different weights but will have the same mass. The gravitational pull that is experienced on moon is 1/6 of the gravitational pull that is experienced on Earth. Again, this is just an additional information. The SI unit of mass is kilograms kg, that is equal to 1000 grams. Next concept is volume. Now, volume has the units of length cube, because volume of a cube is what? So when I talk of a cube, which has all the cube is the one which will have all the three sides same, A, B, C is equal to A. So when I talk about the cube volume, that is going to be A cube, that is length cube. So the SI unit of volume is going to be meter cube, because SI unit of length is meter. So length cube, so meter cube. Smaller volumes are going to be denoted in centimeter cube or decimeter cube units. A common unit, liter, which is not an SI unit, is also commonly used for the measurement of volumes of liquids. See this relation, 1 liter and 1 decimeter. So liter and decimeter cube are the same thing. That is equal to 1000 ml. 1 liter is equal to 1000 ml. 1 decimeter cube is equal to 1000 centimeter cube. So this is how you can remember. The last thing is density. Density we know is mass upon volume. So density of a substance is basically the amount of mass per unit volume. SI unit of mass is kilograms, volume is meter cube. So SI unit of density will be equal to kilograms per meter cube. Density is also expressed in grams per centimeter cube, going in CGS units. And lastly, yes, last but not the least, temperature So there are three common scales that are used to measure temperature: Celsius, Fahrenheit, and Kelvin. So Fahrenheit is going to be related to Celsius as follows. So degree Fahrenheit, always do remember this formula. These formulae are very, very, very important. So degree Fahrenheit is equals to 9 by 5 into degree centigrade plus 32. The Kelvin scale is related to Celsius scale as Kelvin is equals to degrees centigrade plus 273.15. This is something that we commonly know. All you need to remember is the relation between Fahrenheit and degree centigrade. So let us do a question. What is the unit for luminous intensity? So grams, milligrams, candela, all. Option C is the right answer. Next question, 1 liter is equal to 1000 ml? Yes. 1000 centimeter cube? Yes. 1 decimeter cube? Yes. So option D is the right answer. Last question, which is the correct statement? Fahrenheit is equals to 5 by 9 degrees centigrade plus 32. Fahrenheit is equals to 9 by 5 degrees centigrade plus 32. Fahrenheit is equals to 9 by 5 degrees centigrade plus 23. And F is equals to 5 by 9 degrees centigrade plus 23. So 32 is something that you will not forget. So that rules out the options C and D. One thing that you can get confused is whether it's 5 by 9 or 9 by 5. Remember, it's 9 by 5 degrees centigrade plus 32. So this is all about the introduction to stoichiometry. In the next lecture, we will be going into further details of this chapter, and you will realize how application-based questions can be framed from this topic. You can subscribe to our YouTube channel for joining YouTube live classes for best NEET or JEE coaching. You can also download the First Online University mobile app through Google Play or App Store for continuous learning through your smartphones. Keep learning with First Online University, a team of millions of learners and educators worldwide.